Hello, welcome to your 4-1 lesson, using graphs to relate two quantities. Your I can statement is I can represent mathematical relationships using graphs. After today, you will be able to do three things. The first is matching a situation to a graph, so picking the graph that best fits a given situation. Number two, writing a situation from a graph. So you'll look at a picture and then create your own situation that models what's happening. And three, you can sketch a graph to represent a situation. So you will be sketching also. Okay, first example. This is found in your notes, so follow along. Choose the graph that best represents the situation. So each day there are several leaves falling from a tree. One day a gust of wind blows off many leaves. Eventually there are no more leaves on the tree. And then it is important to note that you read graphs from left to right, just like you do any sort of book that you would be reading. And this is also showing that time is passing as these things are happening. And you're moving from left to right, time is passing by. So, for starters, it's important to note each day several leaves fall off a tree. So, there are already leaves on a tree, which is why you'll notice that all of these graphs start somewhere on the y-axis. It's not starting at the bottom at 0, because that would represent no leaves on the tree. So, they all start somewhere with leaves on a tree. And then leaves are falling off of the tree. Because they're falling off, that is a downward slope type of a situation. So it's decreasing in number. So the first thing we want to look at is if we can eliminate anything just from that fact. And we can. Graph A has an upward increase, saying that leaves are being added. So we can eliminate graph A. Once we keep reading, it says, one day, a gust of wind blows off many leaves. So if we're having a gust of wind, and we're blowing off a lot of leaves, that means we're going to be decreasing still, because there's leaves still falling off the tree. But it's a gust of wind, and that's going to cause your downward leaves dropping to increase at a faster rate. Meaning it's going to become even a quicker drop-off. It's falling a lot faster. And then eventually there are no more leaves on the tree, so we have to end at 0 leaves, which both graph B and C do. But going back to the gust of wind, there it's going to be decreasing again. And because we are decreasing even more at a faster, steeper slope, graph B is going to be our correct answer. Graph C doesn't work. If you look at this line right here, that is a constant rate of change, saying that the leaves are maintaining on the tree. So that would only happen if there was like no gust of wind, no wind at all, as a matter of fact. Okay, next example, choose the graph that best represents the situation. So the air temperature increased steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly before dropping sharply. So I've underlined kind of the important words there. And we're going to find what matches. So we have a temperature. It's not 0. It's just there. It could be 0, we don't know, but it is increasing steadily. Okay, so we want something that's going to start going up right away, and then it's going to become constant. Remember from that last slide, a constant is a straight line. Okay, time is still passing, so it has to be a straight line. It can't just be a point. And then, so that would be an increase here, and then remaining constant for several minutes or hours. And then at the end of the day, the temperature slightly increases, which you can see, and then drops sharply. So graph C would be the correct one. The reason we can eliminate graph A and graph B right away is because they both start with a constant rate of change, and for other reasons as well, but that one's the most obvious. So now we're going to switch gears to writing a situation, and you'll have this on your notes as well. So we have a picture here of it is talking about the speed of a car over time. So looking at what's happening here, we're starting at some sort of speed. We are moving. If we weren't moving in our car, we would be down at a speed of 0. So we are already moving, and then it's decreasing. So this car has to slow down for some reason. Okay? We could pick whatever we wanted. Maybe it is braking as on a ramp, as it's making an exit. Okay? And then we notice this straight line here. That's when it's a constant speed. It can't be stopped, okay? Because if we were stopped at a stoplight or a stop sign, something like that, the speed would be 0, okay? We would not be moving at all. We are still moving a speed. It's just slower than the previous speed, okay? So maybe something along the lines of it's now on a road with a slower speed limit. Okay, maybe they were on the freeway, they exited, and now they're on a more of a territorial, a smaller road that has a slower speed. So they're driving on that road for a little while, and then they have to brake again. And now we notice that we have stopped because the speed is at 0. So that's what we're going to write, something along the lines of this. Car slowed down when exiting the freeway onto another road where it traveled the same constant speed for several minutes before eventually coming to a stop. So that situation would fit with the graph that we see. Okay, another example is the height of water in a bucket. So if you look at where we start, we're starting with some height. So the bucket already has a little bit of water in it. And that is going to remain this constant for a short period of time. And then you'll notice that graph starts increasing at a constant rate. So somebody starts filling that bucket with water. Maybe they crank on that hose and now it's really filling fast. Then you'll notice the next change in the graph happens right here, and this is important to note also. We are now still filling the bucket because it's still increasing. But it's not as steep of a line. So think of a bucket when you get really close to the top of a bucket or a water bottle, people tend to turn down the hose so that it's filling slower. So that's probably what's happening here. And then when they get the water height to what they want, now they're going to turn that faucet off or stop pouring water in the bucket, and then it's going to now be decreasing at a constant rate until it gets to 0. So that bucket of water is getting poured out, used up, until there is nothing left. So let's write that situation down. So you should have ended up with something like this based on what we talked about. So make sure that gets written in your notebook or something very similar gets written on your notes. As we start to get to the sketching of a graph, it's important to be able to articulate what's happening in each piece of the graph. So a pelican flies above the water searching for fish. Sketch a graph of its altitude from takeoff from shore to diving to the water to catch a fish, and then label each section. So the very first part of our graph here, we're starting at 0. That would be the takeoff from shore, and then we're increasing. So that bird is getting higher and higher in the air, and then it's going to stay the same altitude, and then it's going to drop off and end up at 0 again. So what's happening here? So the very beginning is the easiest part. That's the takeoff of the pelican, okay? The next section here, the constant rate of change there, it's not increasing in altitude at all. That is the pelican searching for fish. And then the last section here is when it dives into the water to catch the fish. Okay, our turn to sketch a graph. So Henry begins to drain a water tank by opening a valve. So there's water, the water level is full, and we're going to be emptying that water tank. So we're going to have something like this. It's a decreasing. Then he opens another valve. When he opens that second valve, it's going to cause the steepness to increase even more, so it's going to drain even faster. But then he closes the first valve. So now the draining is going to slow down again. And then he leaves that second valve on until the tank is empty, so we reach 0. So something like this is going to be what your graph looks like. All right, next one. When Malcolm jogs on the treadmill, he gradually increases his speed. So we're increasing speed there until he reaches a certain level. He then jogs at this level for several minutes. Then he slows to a stop and stretches. After this, he increases to a speed that is slightly lower than before and jogs at this speed for a short while before slowing to a stop again. So here we go. Your speed, okay? When you get on that treadmill, you're not moving at all, so speed of 0. Increases his speed until he reaches a certain level. So eventually he's going to stop increasing speed, and he's going to maintain that same speed for several minutes. Okay, so that's going to be a little while. Notice it's not just a point, it's a constant rate. He is moving, he is going 6 miles per hour or whatever it is, consistently for several minutes. Then he slows to a stop, so we're going to be decreasing down to 0. His speed is now stopped, and he stretches. During that stretching period, although his speed is stopped, time is still passing. For several minutes, he's stretching. So we have to have that line there at 0. It's not a point, okay? It's still a constant line. After this, he increases to a speed that is slightly lower than before. So we're going to increase again, but we're not going to be quite as tall, if you will, on our speed because we have to be slower. It jogs for a short time now at that speed, so not quite as long there either, and then slowing to a stop. Okay, so making sure we get to 0. So something along those lines is what that graph would look like. All right, so being able to interpret graphs and tables. So house value, we have house A here with the blue line. It costs $100,000. That's the initial starting amount. And then its value increased as time went on. House B, it says, cost less than house A and increased in value at a greater rate. So things to note is that it costs less. That means when I plot my dot here for house B, it needs to be somewhere between 0 and under 100,000. It can't be exactly. Okay, so maybe it's something here. Okay, maybe it's a lower. Okay, maybe it's really low. Okay, maybe it's close. Okay, but it can't be exactly. It has to be under. And then it says it increased in value at a greater rate, meaning that rate of change has to be steeper. So it's going to increase at a steeper line. So maybe it'll look something like this. Okay, so that slope has to be much steeper. So knowing that information, we can use that to find which graph matches. So we already said the red line has to be, house B has to be under, its starting value is under 100,000. So we can automatically cross off number 1 for that reason, as well as number 5. Okay. Then we also know it has to increase at a greater rate, so a steeper line. Number 2 has the same slope, the same increase in value, so that one's not going to work. And then if we look really closely at number 3, you might notice that they're both starting at 100,000. That's not going to work either. And B, it doesn't have as steep of a line. So our answer then is number 4. It started at a lower value, and then it increased steadily, and that line is steeper than the blue line. Last one, which graph displays the data in the table? So the data shows the total number of customers at a car wash after 1, 2, 3, and 4 days of its grand opening. Which graph could represent the data shown in the table? So day 1 was 61 customers. Day 2 is 125. So that is increasing, okay, as we move from day 1 to day 2. So we want to make sure whatever our day 1 is, the next point is higher. So we can automatically cross off number C, or letter C, because if you look at our first point here, our second point is lower, and that's not good. Same with letter D. The second dot there is lower than the first, so we can't have that. And then as we look from day 2 to day 3, that increased again, 125 to 177. Not quite as much of an increase, but still an increase. Okay, and then we have the last one is also an increase too. Okay, so it's really between A and B, but we want to pick one that is the best fit. So if you look from day 1 to day 2, it was a big jump. Okay, and then from day 2 to day 3, it wasn't quite as much. And then day 3 and day 4 was a little bit bigger again. So that's why we want to pick letter A, because we had that really big jump, then not quite as much of a jump, and then a bigger jump again. Okay, so A was the correct answer. That's all, folks. Thanks for listening. Have a great day.